Heyo, Unit Circle Explorers, what's up? So look at graphing today. We're going to continue our approach to exploring properties of the unit circle by doing this unit circle exploration. And um, so here's what you're going to graph. In the printed data table, there are like 5 columns there, right? But you're only going to graph 3 of them, and they don't exactly match maybe the way you'd think they would. So we're going to graph the horizontal measurement. So that'll be the actual measurements that you measured off of your circle horizontally, the vertical measurement column, and the vertical divided by the horizontal measurement. So this is a calculated radius that is highlighted in yellow. So a measurement for horizontal, the measurements for vertical, and the third graph is the ratio you calculated yesterday. Okay, so a couple of words about doing the graph. First, when you make your graph, the x-axis is going to be already made for you, but the x-axis is going to have the degree on it for each of those 3 separate graphs. And the degree, if you have been paying attention, maybe it's just like there's numbers there, right? But if you're paying attention, these degree values are not evenly spaced. You get from 0 to 30 degrees, is an increase of 30. And then from 30 to 45, that's an increase of 15. And 15 degrees to get up to 60. And then it jumps by 30. And then it jumps by 30. So it's not a consistent count. Okay, so when you graph, we'll need to pay attention. That is not the picture to show you next. Because those angles are not all evenly spaced out across the x-axis. So I've just listed part of them. When you are graphing the graph, which is going to show up there on the OneMap screen, it counts by 30s. So any of these multiples of 45, like the 45 degrees, the 135 degrees, there's a couple more over here. Those are going to show up between the axis on the graph. So pay attention when you're placing dots. I mean, you can find where 45 is. It's like halfway between 30 and 60, but just so you know to watch for that. The graph is going to help you out. It is not like super sensitive. Like if you're off by 1 degree, it marks you wrong. Gosh, that would be the worst. It's going to help you out and place your dots for you. As long as you get it pretty close, it'll help you get that placed into the correct place. Any points that you have which are undefined, this would not happen to a measurement value, but for that third and final graph where you have the ratio you calculated, there are going to be some undefined points there, right? We talked about that before. So anything that does not exist, you can error is undefined, is ungraphable, the universe explodes, however you want to describe it. Those points you will not graph because they don't exist. Okay, so you're going along on your graph, and I'll just do a incorrect example here. I mean, these are not data points. This is actually how you would graph. So at 0 degrees, point 30 degrees, point 45 degrees, point 60 degrees gets a point, 90 degrees gets a point. Okay, so for all of the graphs, it's dots, right? You're not like doing lines or anything. You're just plotting the points on here. Let's say, as just an example, I'm going to pick a random number off of my random number list right here. Let's say that 120 degrees I got does not exist. Now, that may or may not be true. That's just a random angle I picked as an example. So when I get to 120 degrees on my little demonstration graph right here, that'll be right here, there is not going to be a point. So I would go to whatever the next thing is, 135, this thing is next. So I put a point here, and then 150, 180, and so on, and keep going, blah, 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 blah. Okay, so any place where you have an undefined or does not exist, you just don't put a dot there, right? No dot on graph. All right, cool, graphs. Have fun, and I'll see you guys next